This video session, we will discuss about how to create a machine learning case study with step-by-step explanation. Here, here we create a machine learning case study using this topic, prediction of health insurance charges. First of all, creating a machine learning case study. Firstly, begins with title name about this case study. It is basically prediction of health insurance standards. And then we upload the dataset using this upload method. This is a dataset prediction of health insurance standards. This is a CSV file, insurance.csv. And then we give a brief introduction about this dataset. In this dataset, this is a health insurance standards prediction model that uses a linear regression algorithm to predict the health insurance service of a person based on the given data. This data set contains detailed information about insurance customers, including their age, sex, body, mass, interest studies, BMI, number of children, smoking status, region, and access to such variable insights allows analysts to get a better view to customer behavior and factors that contribute to their insurance charges. By understanding the patterns in this data setting, we can gain useful insight into how age, gender, and lifestyle choices can affect a person's insurance premiums. This could be of great value when setting up an insurance plan or marketing campaigns that target certain demographics. Furthermore, this data provides us with an opportunity to explore deeper questions such as what are some possible solutions for increasing affordability when it comes to dealing with high charges for certain groups. Here, this dataset contains these column names, that is description, age, the age of the customer, that is an individual, children, the number of children, the customer age, that is an individual, responsive smoker, whether or not the customer is a smoker, that is a boolean, Western region, the customer lives in, that is a string, external charges, the insurance charges for the customer, that is a floating function. Firstly, we import the key libraries using this number, pandas, OS, matplotlib, pyplot, seaborn, and etc. And then we read the dataset using this function, this pd.read underscore csv, and we check the shape portion. Here, this profit is this dataset's name. Here, the shape of the dataset is 1338, H. And then step 3, we check the basic data view of expression. Here we find the information of this dataset. These are the informations. If we find this information, we can understand that here there is a missing value exists. Here, what the values are 100, doesn't they have the pH. Here there is no missing value exists. And then we check the data types using this A-type function. Here, these are the data types. Index is an integer, age is an integer, sex is an object, BMI is a floating point, children is an integer, smoker is an object, region is an object, charges is a floating point. And then we print the first 5 rows of this dataset using this dot header function. These are the first 5 rows of this dataset. And then we print the 10 samples of this dataset using this sample of 10 function. Here, using this function, we print the column names. So the column names, index, age, sex, BMI, children, smoker, origin, and charges. Here, these profit put equal of plus and of function to check the missing value exists in this dataset. Here, product 0, that is, here there is a missing value exists. Here we find the percentage of missing values using this function. And we check the duplicate here. Here we find the value can comes using this function and identifying the garbage values. The step 4, that is data preprocessing or cleaning. Here, machine value handling is not required and drop unwanted. Here we find the discovery statistics using this dot discovery function. Here we calculate the mean, median, standard deviation, and several levels. These are the mean, standard deviation, minimum, Q1, Q2, Q3, and maximum using this function. And then the step 5, that is EDA, exploratory data analysis. Here we conduct exploratory data analysis to understand the data set structure and identify key patterns and correlations. We find the describe this data set using this age, BMI, children, charges. This is a broad plot. So here we displays age histogram. This is a histogram. Age, BMI, children, charges. And then we create a box plot. This data set is index, age, BMI, children, charges. Using this function, in this histogram, here these all are pure and this one is higher one, which is age one. Here, this is higher. And then we create a histogram to understand the distribution of this data set. This is its index, age, BMI, children, and charges. This is a histogram. Here, the x value is index, the y is count. Here x is age and count. Here x is BMI and y is count. Here the x value is children and y value is count. Here the x value is charges and y value is count. And the next step, we create a control dot for finding the gender distribution using these functions. The heading is gender distribution. The red one is female, the blue one is male. Here, using this function, we find distribution of the sex. Next one, we find the smoker. Here the red one is yes and the blue one is no. Here the x value is smoker and y value is count. Count the smoker exists. Majority of this is smoker or smoker. The highest one is not. Next one, the region. We find the distribution of the region using this function. The regions southwest, southeast, northwest, northeast. The next, we find the cost versus region. Here the x value is region and y value is charges. Region and charges. Region wise charges. The region wise The charger highest is southeast. Second one is northeast. Third one is northwest and southwest. And here we find the chargers for smokers in general wise. Here the X1 is size and Y1 is chargers. Here the red one is yes, like Y1, blue one is here. This section is female, and this section is male. The highest charges for smokers in sex wise sex type is male. So we are using these functions, we visualizing the categorical columns. Here the X is smoker and Y is charges. The X is sex and Y is charges. The X is agents and Y is charges. Using this word structure. And then we bring the first five of this data set using this function. In the earlier one, we find the first five rows. Prints. So it's individual, so that is a very received here, using this function, we change the object types into integer types with the sex, the male is 0 and female is 1, sex wise. Here, male is 0, females are 1. Here, these are all males and this one is female. And next, smoker wise, yes, it's 1 and now it's 0. The smokers are good. Yes, is 1, now is 0. And the region wise, the southwest is 1. Oops. Southwest is 1. Northwest is 2. Southeast is 2. Northwest is 3. Northeast is 4. Now northeast. Here, using this function, to change the object types into integer types. These are integers. And next, we find the correlations of these. Like I said, the first age correlations, real-life correlations, charges correlations. Here we display a heat map of these data sets using these functions. These are the heat maps. These are another heat map using these functions. Here, these are x values divided this. Here, we draw the unbounded columns using this function, where x is charges equal to here we import the train test splitting using this function. And we check the shape of this train and the text train dot shape, it's test shape, white train shape, and white test shape. Using these functions, these are the shapes of these X and Y, train and test. Here we create this histogram and those plot to find the changes over different regions. Here the hex value is charges, Y value is count. These are the regions. The blue one is now southwest, red one is southeast, green one is northwest, while the white is northeast. Here, in the distribution of charges over gender, we see that males are substantially charged more because by subconscious behavior. Males are accelerating and they are more likely to take risks, and that keeps them in danger more than their counterpart. It is also evident that males of US are more inclined to get health insurance than female. And in second distribution, we see that southeast part of US is leading in charges. But majority of all customers from all part of US are charged between 0 to 20K only. These are the majority parts 0 to 20K. Here the males are higher one. And here the southeast part of US are leading. And majorities are 0 to 20Ks. And the next one, let's we visualize the distribution of the smoker column containing values yes and no using a histogram. This is a histogram. The smokers. Here, the X value is smoker, Y value is count. The colors are sets. The red one is male and the one is female. In this histogram, it appears that 20% of customers have reported that they smoke. 20% is smoke. We can also see that smoking appears like more common habit among males. Males are common in smoking. This is true for the given dataset only, and so we should always verify if these results of analysis also matches a general definition which we are going to use one model on. Otherwise, the model will assume that in general population also 20% people are smokers, but in reality, it was only 10%. So we would get incorrect prediction. So it is best to check if our primary data matches the result of the general public. These are males, they are doctors, sex male, smokers, yes, count 159. 69. Here, the differentiation of the distribution of the sex, region, and children columns using this histogram board and box tools. So now, guys, and these are charges wise, ages and charges. These is the charges occur with syndromes. Here it seems that majority of our customers have 0 to 1 syndrome. And median charges vary between 8.5K to 11K dollars. Professional canvas. We can also conclude that people who have more children are given less priority in terms of pricing discounts. Having looked at individual columns, we can now visualize the relation between charges, the value we wish to predict, and other columns. We go to the linear regression and SGD regression using this function. These are linear regression. Here we find check the missing value exists There is a missing value assist. Here we show to count of missing values per columns and checking the missing values in the test data. Here's the missing value assist. Here we import symbol inputter, extremes, X test, and here we transform this extreme and X test. Here we fit the imputer on the training and data and transform both the train and test data. Steps here. Now here we fit the linear regression model on the input data using these functions. Here we import schist gradient boost regression using this function, and then we use a regression that can handle missing value directly. Here we print the R2 score using this function in the flight test prediction. These are the hardest scores. And we plot a scatter plot of white test is predicted. X1 value is white test, Y value is white branch. Here, the code snippet creates a pandas data frames the customer data using a Python dictionary and a specific index. These are the Python dictionary. I use a specific index. The index one is 1, age is 15, EM is 25, sequence is 2, small of 1, engine 2. Here, after loading this as function, the answer is here. This table represents a customer with age, BMI, number of children, smoking status, and aging attributes are stored in a structured tabular format. These are it's like a structured tabular format, and then we predict the cost using this linear regression prediction. This first table. Here we find the medical insurance cost of a new customer using this function. These are the predicted costs. After code this function in conclusion, our project on predicting health insurance services highlighted the integrated relations between various persons and demographic factors and the resulting healthcare cost by analyzing key variables such as age, gender, medical history, lifestyle choices, and geography location. We have developed a robust model that not only estimates annual healthcare expenses but also offers insight into the underlying trends affecting this cost. Here, overall, this project not only serves as a valuable tool for stakeholders in the health insurance industry, but also contributes to a greater understanding of how personal choices and circumstances impact healthcare costs.